This is the Proster IP64 compass. They're one of the most common compasses which are sold on the internet, probably because they're so cheap. And I haven't been able to find any websites or videos telling people how to use them. So I thought today that I would show you how to use them. I'll go through all the parts and features of this compass, and then I'll show you how to use it either with or without a map, and also how to deal with declination. I'll also look at all the other built-in features, and I'll end with a very quick subjective review. Normally I don't do any preparation when I'm making videos. I just tend to think of something that I hope may be interesting and stand in front of a camera and chat away. But what I've done today is I've actually done some preparation, which you'll be surprised to know. I've just spent a few minutes looking at this compass, and I've tried to write down everything I can find on this compass, and I found 18 features. So if I do miss any and you've got one of these compasses, please let me know in the comments box. So to start with, what I'll do is I'll go through all the individual parts on the compass, just so you know what I'm talking about later on, and then we'll go through how to use each section. We'll start at the bottom, and here we've got the sighting notch and the thumb loop. And then next we've got a lens with an adjustable focusing dial. We've got an inclinometer scale, which is this scaling here. And we've got the actual inclinometer, which is this metal part here. There's a metric ruler, which runs up the side of the compass here. That's obviously in centimeters. Here we've got the sight line, which is the black line that runs down the center of the glass. And in the center of the sight line is a reticle. There's a prism at the top of the glass. I haven't actually been able to work out what this prism's for. I can't see any point in it whatsoever. Anyway, down this side of the compass, we have a 1 to 25,000 scale. So if you're using a 1 to 25k map, this is what you'd use for your distances. On the actual dial here, we've got the index line, which is just next to the 8, and we've got a spirit level, which is here. We've got a luminous bezel, which is marked in degrees, going around the edge of the bezel. And we've also got a bezel prism, which is here, this part here. And the prism is actually at the end of the north line, which is this line here. And there's a small green triangle on the north line. Inside the compass itself, there's a magnetic disc marked in degrees and cardinal points, north, south, east, west. And on the back of the compass, we have an estimation table, which is all this lot, and we've got a tripod mount. Oh, number 13, the luminous bezel. I think it's number 13, that's what I said. The luminous bezel. This arrow ends on the north line here, and also the arrow, the orienting arrow inside on the disc itself. They're all luminous, but the luminosity on this particular compass is so low, I wouldn't feel confident in saying that it can be used in the dark. Anyway, that's all the features that I can find. So hopefully that's 18. So now let's go through how to actually use this compass. Firstly, how to take a compass bearing from a map so you can follow it from somewhere to somewhere else on the map. There are two ways to do this, so today I'll go through both methods. Oh, just one point here. As you can't see the map through the compass, normally you would need to use one of these, a protractor. But as most people don't actually carry a protractor, today I'll be doing everything today without using a protractor. The first method uses an oriented map, and the way to do that is open your compass and rotate the bezel until the 360 is directly over the index line, which is don't forget, it's a small black line at the top of the bezel. And then put your compass on the map and line it along one of the these vertical blue lines that you can see on the map. These are the eastings. Next, just rotate the whole map with the compass on it until the arrow on the north line is directly over the arrow on the disc. So your map is now oriented. Without moving the map, leave the map there so it's oriented still. All you're going to do is decide where you want to go to. So let's have a look. So let's say that I'm stood on this small mound here and I want to go to the trig point on the top of pole bank. Put the compass so it's touching your start point and your destination. So it's like this. And then all you do is look down through the prism on the glass, and I can see that I've got a compass bearing of 322 from there. So that's the first way of getting a bearing from a map. The other way of taking a compass bearing from a map doesn't need it to be oriented. The map can be pointing in any direction. It makes no difference whatsoever. All you do is open your compass. Once again, we're going to go from this small hill here up to the trig point on pole bank. Put the edge of the compass so it's touching your start point and your destination, and then simply rotate the bezel until the north line is pointing straight up the map. It's pointing directly northwards, and then you read the bearing from underneath the index mark, which is here. And as you can see, we've again got 322 degrees. Before you can follow a compass bearing in most parts of the world, you'll need to adjust for magnetic declination. And as you've gone from a map to a compass, grid to mag, if you live in an area with a west declination, you'll need to add the amount of the declination to the bearing, the map bearing. If you live in an area with an east declination, you'll need to subtract the declination from the bearing that you've just taken from the map. Once you've done any of these required adjustments, to follow a bearing, you can either look through the lens and then simply turn yourself until you can see the bearing behind the red line that's in the lens. And then you look through the sighting notch and the line, and then find something that you can walk to, go there, and then repeat that again. And you keep on doing that until you get to your destination. Oh, the reason that you have to hold it like this, by the way, is that normally you would hold a prismatic compass like this. But in this case, because of the shape of the thumb loop, you can't actually put your thumb through the loop. Another way of doing it is simply hold the compass in front of you, sort of chest height, and then turn yourself until your compass bearing is directly under the index line. Look for a feature, walk to that feature, and then keep doing that until you arrive at your destination. To find a feature on a map that you can see on the ground, as an example, let's say that I can see something in that direction and I want to identify that on the map. The first thing to do is look through the lens and turn the focusing dial until you can see the numbers clearly through the lens. You should be able to see two sets of numbers. The black numbers are the actual bearing itself, and the red numbers are the back bearing, or some people call that the reverse azimuth. Don't forget that in most parts of the world, you're going to need to adjust for the local magnetic declination. In this case, you're going from a compass to a map, so that's mag to grid. So you just need to do the opposite of what I described earlier. I'll put a link in the description box to the waves video, which it explains all about declination and how to adjust your compass. You hold the compass and you look through the notch and place the sighting line on the feature, and then you read the bearing through the lens. So I've got my compass bearing and I found out it was 214. So let's say that I'm stood in this car park here. So all you do is set 214 underneath the index line, which is there. So this 210, 220, so 214 is there. So we've set 214 underneath the index line. Put the edge of the compass so it's touching your location, which is here. Don't forget this car park. And then simply rotate the whole compass until the north line, that's this line here, is pointing directly up the map. So it's pointing northwards. This is north. So keeping it touching where you are, your location, and that north line now is pointing directly up the map. So the hill that I was looking for on a bearing of 214, I'm here. It must be along this bearing, and there's the hill. So I'm stood here, and there's the feature that I identified. Unlike the vast majority of Chinese compasses that are all over the internet. These are actually quite solidly built metal compasses. They even give you an email address to contact the manufacturers, and surprisingly, a limited warranty. So this isn't what I would imagine most people would expect from a Chinese compass. You know, but I think it's okay. But there are some things that you need to be aware of, and the main one I would say is that if anything is likely to break on this compass, it will be the inclinometer. So my advice would just be simply remove it. Obviously, if you're a geologist where fractions of a degree in rock layers can make a big difference, then you need a good quality inclinometer. And in this case, you're not going to be using one of these compasses. But for just walking around the countryside and the hills, an inclinometer in a compass, I've always said, is just useless. You don't need them. If you really want to know the angle of a slope, all you do, set your compass at 90 degrees. So 90 is underneath the index mark. Point the compass at whatever it is you want to get the slope angle of, and then rotate the bezel, in this case, until the north line is pointing straight up. Most compasses would be the orienting lines, and then simply read your bearing. And in this case, I've got 70. So in other words, the difference between 70 and it started off at 90, so that slope angle is 20 degrees. You know, it's inclinometers, you don't need them. Don't believe the marketing hype. Just learn to use your compass. To get the distance between 2 points on a map, the simplest method is to either use the ruler on the edge of the compass or to use the 1 to 25k scale. This is a 1 to 25k map. So to measure between 2 points, you just put the 0 on one of the points and read the meters on the other point. It's really simple. If you're using another scale map, say 1 to 24k or 1 to 40k, then you'd use the metric ruler. Don't forget that millimeters are always equal to the map scale. So if, for example, you measure 85 millimeters and you're using a 1 to 24k map, it's 85 times 24, which is 2040. With a 1 to 40k map, it would be 85 times 40, which is 3,400, etc. If you're using a 1 to 50k map, I'd suggest still use the 1 to 25k scale, but then just double the distance. So if you measure 2.5 kilometers on the map and then double that, the distance is 5 kilometers. That's really all the basic functions of this compass, but there is one extra item on the back, which is quite interesting. I call it the estimation table. It does take a little getting used to, but you can use this table to give you some approximate distances. I won't go through the entire table, but I'll give you a brief introduction. As an example, to get the approximate distance to something, you would use the first and the last columns. If you know the width of an object and you know the angle in degrees from one side to the other, you can use the scales to get its approximate distance. To find the angle, take a compass bearing to the left and the right of the object, and the difference is the angle that you'll need. As an example, if something is 2 meters wide and the difference in the bearing between the left and the right is 12 degrees, you can look in the first column to find 12, that's 12 degrees, and in the last column it will say 1 to 5. So the distance to the object is approximately 5 times the width, or 10 meters. It's actually 9.4, 2 divided by tangent 12. I did a video on military compass calculations, which this will show you how to work it out. I'll put the link in the description box. The distance that you'll get from the scales on the back of the compass are horizontal. So the scale assumes that the object are at the same height as you. If the object is higher or lower than you, once you've got the angle to the feature, if you know the distance, which we've gone through how to work out, which if it's a regular object, normally a gate or a tree or something like that, you'll know what they are. In this case, what we're going to do is we're going to look on the back of the compass and we're going to use the fourth column. Again, this will only give you an approximate figure. As an example, if the distance is 1, 2, 3, 4 meters and the angle is 17 degrees, look in the first column to find 17, And then in the same row, the fourth column shows 30%. So the height of the object above your location, according to the table, is 1234 times 30%. So the feature is 370.2 meters above you. It's actually 377.2, which is 1234 times tan 17. Again, this was explained in the military calculations video. Next, a quick review, and this is only my personal subjective opinion, so some people may disagree. Okay, firstly, these Chinese compasses are slightly unusual because they're actually quite well made. They're nowhere near the quality of the major compass brands like Sunto or Silver, etc. And as they're made from metal and glass, they are really quite heavy and they weigh much more than virtually all other compasses that I've come across. The lens works really, really well, and it's easy to get an accurate bearing once the dial stops moving. Although this does take quite a while, probably due to using really cheap magnetic material for the disc. Obviously, there are some things which I think could be improved. Whether it will do or not, I don't know. As an example, the dial itself is 46 millimeters in diameter, but the glass at the top is only 41. So if the size of the glass was increased just by a small amount, and most importantly, it was actually centered in the lid, once you'd set the direction, you could actually use the compass with the lid down. Also, as I said earlier, if I was going to use this compass for my own use, I would definitely remove the inclinometer, as it's not useful at all, and it really will look, it looks like it will be the first thing to break because it's quite flimsy. Also, if you take the inclinometer off, then you'll be able to use it, if the glass was moved, you'll be able to use it sort of with the lid down when you're walking around the countryside, you know, which is what most people want to do. I would suggest that most people buy these compasses because they cost £16, $20, 19 euros, and that is less than virtually all compasses from the major brands. And this could be a really good compass if the manufacturer was willing to change just a few bits and redesign it. But obviously then they'd have to redo their factory processes, which is I doubt if it'll ever happen. As an example, if you look in the post section that I did yesterday, the post section of this YouTube channel, I gave an example of how to improve compass roamers. That will allow compasses to be used with virtually any map in the world. Will the major brands use that suggestion? No, they won't. You know, even though their compasses will be cheaper to make and more people can use them, so they'd sell more, it's not going to happen. Oh, this is called a Proster IP65, by the way. IP65 is just a rating system. IP means ingress protection, or what can and can't get into the compass. For the 65, the 6 just means dust protection. So it means the compass is completely sealed against dust. The 5 just means it's protected against low pressure water. That's light rain to you and me. It can't be submerged in water. If it was IP66, that would be better for outdoor compasses, as that would mean it could handle being splashed. You know, like when you're doing a river crossing or out in heavy rain, which is very common in England. If it was IP67, you could actually hold it underwater 1 meter deep for up to 30 minutes. IP68 would mean it was protected in deeper water for a longer time. IP69K, which is normally used for things like industrial cleaning machines, the components there will stand high pressure, high temperature water jets. But remember that an IP rating just means ingress protection. So it has nothing to do with impact protection, which is what people going out walking in the hills are more concerned about. You know, if I drop it, will it break? But for that, we'd need to look at mil standard, what is it, 810H, but that's another video. Anyway, what was I saying? I almost started to waffle then. I hope you now have a better understanding of how to use these Proster compasses. Thanks for watching.